Okay, we're going to continue with the Semester 1 final review for Algebra 2, this time problems 33 and 34. Problem 33 has three parts to it, and I'm going to start on part B. And this actually is problem 33. I didn't change it. So even though it says model 33, this is number 33. Okay, for part B here, we're looking for the solution to these two linear equations when they're graphed. It's the place that's common to both of them, in other words, the point of intersection. So whatever that x and y value is, that's your solution. And so this problem has one solution, and we call these independent systems. Okay, an independent system is one where the lines cross and you have one solution, namely that intersection point. So wherever that would be located on the graph, that x and y combination is your solution. So if you have parallel lines, going back to part A, parallel lines actually do not cross each other, so there is no solution to these. And this is called an inconsistent system. And there's no solution. Now, if you were solving this algebraically, you would end up with a statement that's never true, like 6 equals 8 or 0 plus 0 equals 11. Anyway, you'd end up with a solution, a statement somewhere that just can't be true. Never true. Okay, part C is actually the same line graphed on top of the same line. In other words, this really is two lines that are the same line in disguise. We call this coinciding lines. And so if you're looking for the place where these two lines touch each other, there's millions and millions, an infinite number of spots. And, you could picture me coloring in these places that are on both lines forever in both directions. So these have infinitely many solutions. It's called a dependent system. Dependent, and it has infinitely many solutions. So if you were solving this algebraically, you'd end up with a statement that's always true, such as 0 plus 0 equals 0. That'd be a common version. Or 6 equals 6. Okay. Example 34. We're going to solve this algebraically, and I'm going to use the elimination method here. And you're going to start with multiplying the top and the bottom in order to eliminate the x value. Here we're shooting for a 6x and a negative 6x. The top line just has to be multiplied by 1. In other words, it's good to go. The bottom line has to be multiplied by negative 2, which then takes us down to this line. Adding the lines eliminates the x. And dividing by negative 12 gets us the first answer, which then we plug into the original problem up here, the original first equation. It actually works to plug it in either one. But if we put it in the y value here, we end up with 6y plus 6 equals 30. Subtracting 6 gets us 6y equals 24, and that tells us y equals 4. So our answer in point format is 4 for the x, negative 3 for the y. And that takes us through those two